We are now going to take a look at Spherical Scenes and Planetary Terrains. This primary feature was added within View 7.5. It does have some changes with the way things work in View 8. But for the most part, it's pretty much the same as 7.5. But we are going to take a look at how some of the objects are modified, and also the difference between a spherical scene and planetary terrains. So to enable this, we're going to go to File and Options, and under Units and Coordinates, we can enable Spherical Scene. What I also want to do is change my internal unit to 1 meter. Since we're going to be working with a larger scene, overall, internal unit of 1 meter seems to work out pretty well. Although we will take a look at some of the other ways to modify this. Okay, so I just have a ground plane in the scene, and we're just using a spherical scene. And going back, if we take a look within the options, we can see we can set the scene radius. Earth's radius is approximately 6,400 kilometers. And by default, it does automatically set the scene to that. I do want to note that making changes to the internal unit once spherical scenes are enabled, it will modify the scene radius. So if we take a look, and in our different views, we can see that our ground plane, instead of being completely flat and shown as a line, is now starting to curve. The higher we raise up the camera, the higher the more the scale changes and extends on the infinite plane, and eventually becomes pretty close to a half circle. It will eventually stop. It's actually more about a third. We can also see that in the main camera view we have no preview. So if we go to File Options, Display Options, we do need to increase the distance in order to be able to see what's actually going on within the scene. So we can start to see the changes in the atmospheric effect. But really, I mean, this is only going to allow us to extend so far from the object itself. It is curving infinite planes, and it'll also manipulate terrain objects. So we just add in a regular procedural terrain, increase its scale to a decent size. And we bring this down. We are not really going to see the curvature on just a regular terrain. On an infinite procedural terrain, we'll go ahead and load one in. It's going to ask if I'd like to replace the existing ground plane, add the sea. I'm going to select yes. And now we have that curvature of the object. So we do have to use an infinite terrain in order to get it to curve. So those are really the only objects that are going to curve. The clouds themselves will also curve within the atmosphere. So if we go to the atmosphere editor and add a cloud layer, just using dark cumulus, you will see that the atmosphere does conform to the spherical scene. So this allows us to not have to worry about using lens aberration in order to fake the curvature of a planet. I also want to note that it does change the way aerial perspective works. Aerial perspective becomes a fixed value. This is based on the scene radius and the overall scale, and it's going to create something similar to Earth. So we no longer have the ability to change the aerial perspective once spherical scenes are turned on. Same thing with planetary terrains when you're using them. So if you need to adjust the atmosphere, maybe raising it up, the best thing to do is adjust the sky mean altitude. And then you can also decrease density if needed for the sky ground density. And that way you can raise up the mean altitude a little higher, maybe increase the thickness of the atmosphere, because if clouds extend beyond the range of the atmosphere, they get cut out. And in order to be able to fully see them, you do have to increase the mean altitude. But the problem is, even with different exposure settings, it might be a little too thick. So then you can decrease density, and that's a good way to compensate for that. You will also notice that in the atmosphere editor, the only atmosphere models that are available are the spectral model and the environment mapping model, which means we can use HDRI lighting, which will then remove spectral clouds from the scene. And if we get rid of the haze and fog, we're just going to see that default black environment map. We can invert it, see that it's going to show up white. But those are the only two modes available within Planetary Terrain scenes, Spherical Scenes, and the standard model, volumetric model, no longer available because it does use the advanced atmosphere 3D atmospherics from the spectral model in order to create the atmosphere. If I switch over to the front view here and we take the main camera and move it, we're going to be able to see that infinite planes will move with the camera to go all the way around the scene. And the coordinate system is basically still the same until we hit the edge, which we can see it does end. So you can only go so far using a spherical scene, which is where the planetary terrains come in. We're going to go to File, Options, Units and Coordinates, and use Planetary Terrains. Now, this will also modify ground planes as well, which are an infinite plane. It's not just restricted to an infinite terrain, so you don't even have to use an infinite terrain to create some of these scenes and take advantage of the atmospheric effects. So we can now see we have a full circle and an entire sphere for the default procedural terrain that's loaded into the scene. I'm going to go ahead and delete it. Now we're just going to see the C object. And we'll go ahead and delete that too. And I'm going to add in a ground plane, which is just an infinite plane, and probably in this case has the water material added to it. And that's because it was the last object I had selected. So I'm going to load in large scale pale grass, ignore the alpha information. And now we can see we have a spherical ground plane. I'm going to go ahead and move the camera out. Now, a really good way, and pretty much one of the only ways to manipulate the camera effectively, is to go through the different viewports and kind of move it around. I do want to note, once you hit the bottom, however, it can be difficult to manipulate, and sometimes the camera can lock in place because it does become the end of the scene, and we can't move past that point. So we can go around in both directions, and it will eventually stop. So we also have, if we go to File and Options, the ability to change the planetary mapping center, latitude and longitude. So this way we can set a value. Let's just go ahead and type in something random. Let's do 50 and 65, which is going to essentially change sort of the pivot center of different parts of the scene, and also work with some of the different maps that are available. So let's take a look at a scene I've already got set up. And in this scene, what I'm using is just the ground infinite plane, and the material. I'm using some 10K maps of the Earth, where I have just a projected texture map set to automatic mode, which is automatically going to wrap around our sphere and map correctly. And I've got a bump and a highlight and reflection map in order to get the water to work correctly. So this is one way to create a planetary map and create a planet. Now, you're probably thinking, well, couldn't we just map this to a sphere and not have to use a spherical scene? Well, yes. The only thing is, then we can't use the atmospherics. And the clouds are a really amazing feature when working with spherical and planetary terrains. So I'm just going to clear out the atmosphere I have and add in, let's use the dark cumulus preset, and we can adjust the height. And right now it's going to be a very, very basic sky. We're going to see a lot of repeating within the clouds. So there is a new feature that was added in 7.5 and now expanded on in version 8, and we'll take a look at that in just a second. But what we can see is, for the most part, it's just this very small fractal. Doesn't really work for the size of this planet. So what we can use, if we go to the atmosphere editor and edit the cloud, is there's a large scale density tab now. What we can do here is load in spherical maps in order to distribute the cloud layer. Subtract based on the density, and also increase or decrease height. And these work with grayscale maps. So I'm going to go ahead and load one in. And here I have a planetary cloud map based on Earth's atmosphere and generated from various satellite images. What we can do is adjust the density map offset, X and Y degrees, which is going to be just like using the latitude longitude. Now, this is not going to exactly match the mapping set for the ground plane, since I'm using a projected texture map and not a planetary texture map. And that's the feature I was talking about that was added in version 8, and we'll take a look at that in just a minute. First, what we can do is adjust the influence on density. So the grayscale amount and its influence on basically the transparency of the existing clouds, the height of the clouds, and then we can also use the limit wall effect. And a wall effect would be basically a very sharp cutoff between the black areas of the map and the white areas, where it would just create a very harsh wall in the cloud. So this will limit that and create a little bit of a better transition around the edges. We can also adjust the cover amount, and with a cover of 100, it's going to pretty much rely entirely on the map itself. And you can also see that the preview is difficult to see. So if you're relying on the preview in the material editor, one thing you can actually do is, I'm going to go ahead and increase the offset of the density map to an X250. And now I can start to see a preview. So I can always reset that back, but if you're looking at the preview, it can be helpful. And we could also modify the scale of the cloud layer and the cloud material, and even change some of these settings for the overall density production. But basically, it's going to use a bilinear image interpolation mode in order to really smooth out and very effectively allow you to use these maps and image maps, even low-res ones, to really improve the look of the cloud layer. So some options you may want to turn down, possibly the sharpness, and really going in and modifying to adjust some of these cloud layers to work from such heights. I'm going to go ahead and increase the height, increase cover, and decrease the overall density to begin with. And then decrease sharpness. And I really don't want to use feathers with this, at least not on this specific layer. And then we can start to improve the quality. We can adjust the shadows if needed to give us a little bit of a better transition. So we could set up multiple layers as usual, so we're not just restricted to one cloud layer. Set up different cloud maps and create some pretty amazing planets. So even with just using the infinite ground plane, because of the atmosphere and some of the features available with that, you can really create some amazing scenes. I do want to note that the material, one of the options I have on here is to increase the contrast. This is the diffuse edge and will allow us to create a much more realistic fall off around the edges and shadowed areas of the planet. So let's take a look now at using procedural terrain. And I'm going to go ahead and delete this ground, and now we'll just see the atmosphere. So that's also a good way to just look at the atmosphere, which is kind of neat. So if you just want to have an atmosphere and nothing else, that is possible. Although pretty much impossible to view within the viewports. So what I want to do is load in one of the current Infinite terrains. And I'm going to use the red rock and sand. And it's going to add our sea level object because I had deleted the other one. And now we can take a look and we'll be able to see a preview showing. So now what we have in this scene is the ability to grab our terrain and move it in to the scene. And having an infinite terrain, it's going to give us, of course, as much detail as we need. And you can create an entire planet with this method. So if you're using a dynamic population, you could create forests and really create an actual entire planet, which is pretty cool. I'm going to go ahead and zoom in, just get us underneath that cloud layer so we can take a look at the terrain. And we can see the atmosphere is pretty intense right now, for the most part, but we can start to see that terrain. So if we want to have something defined a little bit better, now one thing we could do is just increase the overall scale of the procedural terrain and the function that's creating it. And that way we could have a lot more variation overall within the terrain. We take a look, edit the object, go into the procedural, and really just increasing the wavelength would be a possibility. But I'm going to show you something we can do. I'm going to add in one of the new nodes, which is a texture map node, Planetary Projected Texture Map. This is going to work just like I was showing with using the ground plane, where it's going to wrap around the planet, but because we're working in an infinite terrain which kind of has a different coordinate system, it would be difficult to set up that same operation. So we can instead use a planetary projected texture map. We can also use this to define cloud layers if you want to define it within the function rather than using the large scale density. So one of the maps I have is that Earth specular map. And what I can do is first invert it so that the continents are going to be white, and use it to control the gain of this terrain fractal. This will lift up areas to form continents and drop down areas in order to create the ocean floor. And it's automatically going to map itself around the sphere. We could even change the latitude, longitude within the map. And I do want to note it's a grayscale output. because there are other methods to use the color, and then we can adjust the sea level to fall below the terrain to show up correctly. As we can see, there's that OpenGL error, which is caused by the near distance. Go display options, and I'm going to set my near plane distance to, let's go ahead and set to 2 kilometers. And now we're going to be able to get a little bit of a better preview and not so much tearing. I'm going to turn on the sea level, and we might need to raise it up above the terrain in order to get it to cut off. I am going to zoom out or grab our camera, move it a little farther away from the planet. And it looks like we can now increase this near distance, increase it a little higher. We can also take a look at the main camera and how far it is on the Z, which right now is 50 kilometers, so that means, or that would be a little over 5,000 kilometers, sorry. So I could easily bring it up to 2,000 kilometers for the near distance and get a little better representation of the intersecting between the sea object and the terrain. Which means I can go ahead and lift this up, and we should start to see it coming through the terrain once we reach a certain level, and be able to preview it. And I'm going to reduce the atmosphere density a little. Actually, I'll just go ahead and turn off the clouds for now, and then we can just take a look at the planet, not have to worry about the clouds at the moment. And then reduce density, and that way we'll be able to see the sky a little bit better. For the most part, we're still just seeing the terrain. We're not seeing the water yet. So I do need to raise it up a little higher. Let's go ahead and set it. First, what I can do is select the terrain and take a look at its scale, which we can see is very difficult to tell what the actual amount is. And I also want to note that you do not want to adjust the scale. X and Y are, of course, stretched to the entire scene, and then the Z scale is kind of automatically adjusted. If you need to, just increase the gain output of the procedural terrain. So let's go ahead and set this to 1 kilometer and see if we can get a little bit of a better preview, and just want to get it to start intersecting with the terrain itself. And it might be a little too high, so we might need to just take a look at the terrain. Oh, and I was adjusting the wrong object. Okay, so we'll go back, select the water, and take a look. Bring it down. And we can start to see that in the preview showing up a little. Let's go ahead and set it to 100 meters. And sometimes you just gotta give it a try, bringing it up slowly in order to get it to work correctly. The easiest thing to do is really look at the output of the procedural terrain. So edit the function and take a look in the output, and what we can see is that drop off is really not very large. So if we have to, what we can do is modify the output in order to increase the gain, because right now it's not even falling below 0. And most of the range is between 0.5 and I'd say around 0.75, maybe 0.7. So we'll go ahead and use a brightness and contrast, decrease brightness, increase contrast, and give us a little bit of a better range to work with. There are other modifications we can also make. For the most part, that planetary terrain is going to clip out, and we're not seeing it black. It's not going to reach the lower ranges. so it will sometimes cut out. So we'll just take a look and see how this is going to show up in the preview. It's still being completely overwritten by the sea. So we'll go ahead and set this to 50 meters and take a look. And in this case, it does look like there are a few problems. One is probably because I didn't set the interpolation type on the planetary map. So let's open up the function, and we do need to make sure this planetary map has an interpolation type, and bilinear is going to work the best. So now the output, if we take a look, is really only between that range using the planetary map. So if we have to, we can adjust with a filter at that offset, or with this connection to the gain, which should be able to give us something a little bit better. And we can start to see the impact of that a little more. And we can always just use a regular filter if needed to give us a more harsh contrast between the two. And this might be a little exaggerated, but we should see it a little better. And now even within the terrain editor, we can start to see those areas. Of course, in this case, it looks like the terrain might be dropping off and going below the range which we are going to need. So what I can do is adjust the filter and pull it up a little bit, and then if needed also do that within the function. And we can also force the extension on the terrain to raise it up. There's a couple of different ways to modify that. So we'll go ahead and take a look at this and see if that's going to work out. We're going to take a look at another way to be able to create this sort of an effect. Because in this case, even though the output seems correct, there are other ways which will probably work out a little better. So I'm going to delete the filter, and what I'm going to do is use a combiner. And setting the combiner node to blender, I'm going to add in now a constant number value of 0 should work. All right, let's go ahead and set it to -1. We can always clip the ratio if needed. And then attach this blender to be controlled by the planet. Get rid of that gain connection. And if we have to, we can just invert to get this to show correctly. And we should be able to now blend between just a constant and then also have the terrain fractal. So now we can see that much better. I do want to note that with the planetary mapping mode, the preview in the terrain editor isn't going to be exactly what you see at render. It's not going to wrap around always. And now we're seeing a much better transition between the two. And of course this material is way too small in order to show up as a nice variation. So I'm going to add a few more zeros to that number for the scale of this material. And we can get something that looks a little bit better. Do need to pay attention to those material scales. And a lot of that is going to depend on the internal unit. Because all of that will be manipulated. And you'll probably need to make a few adjustments and tweaks to the image offset or latitude longitude of the planetary map to get it to match a color map, which you would have to use the object parametric mode to wrap around. One cool thing you can do is also use planetary maps to distribute mixed materials in order to give a much better variation overall. And this even allows you to use the sea object to add coastal foam if you want. So there's a lot of control you have. I'm going to go ahead and we're going to take a look at another way to work with some of these planetary terrains. So creating a new scene, going to units and coordinates, enable the planetary scene, planetary terrain, and decrease the size and scene radius down to 1 kilometer. So what I'm going to do is first reset my display now to be 1 meter for the max distance, and we can go ahead and use let's use 2400 kilometers for the far distance. And now load in Infinite terrain. And with these small scenes, what we can create are really interesting planets and asteroids, things like that. Also have a little better control over the scale sometimes, but the atmosphere in this case is going to be a little off. If we add a cloud layer, let's go ahead and just choose one of the presets. I'll use dark cumulus again. And if we take a look at the height and the altitude, we're at 2 kilometers, which is already twice the size of the radius. So let's go ahead and bring the altitude down to 0 and set the height to something a little higher or lower than what it was. I'm going to bring it up now. Let's do 490 meters, and we can see how far around this object it's going. Take a look at the preview, and we can see what that looks like. It's fairly interesting. So if you need to work with something a little smaller, it is possible, but keeping in mind that if we take a look at the atmosphere, it's pretty much just off right now, because it is based on that overall amount. If we reduce the mean altitude to a very, very low amount, we should be able to compensate, but it's still going to give us some problems and not create the same sort of look as we had before. So though it is possible to create scenes like this, because of the scale differences, the atmosphere just won't look as good because we don't have the ability to adjust the aerial perspective. You can modify the internal unit to try to improve the overall look. Let's go ahead and set this to 1 kilometer and take a look at the scene, and what we can see is that the atmosphere is now about the same size. The terrain is completely different than it was and doesn't look great. We can increase the height in order to show more of that fractal, and now we're starting to see a little more of an accurate atmosphere. But as you can see, if I increase the mean altitude, it's going to jump to a very high level. So it does take a little more playing around with and using units you're not used to. Sometimes what's going to work best is, instead of using the typical display units, metric, you might need to use a view unit, which is the original unit of view back in version, possibly version 6. Version 7, they made a lot of changes, but a view unit is the true unit of all objects, and it might give you a better idea of how to adjust scale. You can adjust the z-scale with these terrains, but it can cause some problems and sometimes resets them with the larger scenes. In this case, it'd be a little easier to modify it, but you can pay attention, and using a view unit sometimes get a little closer to what you're looking for.